Welcome to another Qdrant webinar. My name is Kacper Łukawski and I'm a senior developer advocate at Qdrant. We are building the vector database, which is an important component of many semantic search applications, including retrieval augmented generation. And today's webinar is all about cloud inference, a brand new feature we have introduced a few weeks ago, which was a kind of the most requested feature of all the times, I would say. I can't even count how many times I was asked the question of how can I create the embeddings without setting up any model? And that's why we decided to add this missing component into our managed cloud solution. And during today's webinar, I would like to present you how to build an end-to-end application that will use that feature so you can forget about setting up your models either locally or using any of the inference providers available, and you can just send your raw data directly to Qdrant. And before we start, let me just briefly describe why I think it is so important. This is a typical scenario. Whenever you implement a retrieval augmented generation pipeline, there are two processes at least. The first one that involves building your knowledge base requires you to take data from all the data sources you want to support, pass them through this process of loading them, splitting into different chunks. And I won't be speaking much about chunking, obviously, but the whole process also requires to have some sort of embedding machine that will be taking your data and converting them into their vector embeddings representations so they can be fed into the vector database. And similarly, during the retrieval phase, you had to pass the queries or questions as sent by your users through the same embedding machine, so they might be just compared to the document embeddings later on in the vector database. Apparently, for many people, a huge blocker in that process was hosting the embedding model. Obviously, if you do not see much traffic in your system and you need to maintain a model on your own, it's a waste of resources. These models are pretty hard to be run in a serverless mode. And so definitely there has to be a server running 24/7, even though you may be receiving just a few requests every single day, or maybe you have just a lot of data to ingest at the time when you create a system, but then the model itself is just rarely used because you perform search on an existing vectors. That's why Cloud Inference introduces a new mechanism that is capable of creating these vectors on the service side. It doesn't mean that we just incorporated the models into your cloud instances that you create in Qdrant Cloud. That would be a huge overhead, especially if you use the smallest instances, and running these models typically require having some GPUs. So that's why we created a separate service, an inference server, which just communicates with your cloud instance. They run in the same region, so the latency is negligible. So you can just send your data using the client, the SDK that you use in your project, and then the server will just handle the rest. However, no additional load will be created on your specific cloud instance. So this is how to have the best of both worlds. So you can still use the best model possible, but don't need to worry about the actual maintenance of the embedding models in production. And moreover, you can also use these models for free if you do not work with like huge loads of data, because we provide free tokens every single month for each of the models. So you can test it out without paying literally any cent. And let me just start with a short review of how that looks like in Qdrant Cloud. So I'm currently sharing, this is my personal account on Qdrant Cloud. I have a couple of clusters running, but let me just create a new cluster. When I do that, I can select a cloud provider in regions. However, cloud inference is currently available only in American regions. So let me just select one of them. And yeah, actually, I don't need to select anything else here. The default setup should be just fine. Obviously, if you foresee to have lots of data, then probably increasing the amount of memory or the number of processors makes a lot of sense for setting up high availability. However, in our case, that should be just enough for our little test. Let me create a cluster, and once it's created, we should be just redirected, yeah, into that window. Let me just close the dialog, and here we have a new inference tab. Okay, I just forgot to create an API to copy the API key that was provided. So let me just create another one. Let's say it will expire tomorrow, and it will be just general purpose API key that will allow you to manage all the cluster and write and read from all the collections. So when I create it, I will just copy it to my clipboard, and now I should be able to use it. So my cluster has been already created. I can open the UI by clicking on this button. And then I just need to paste the API key that I've just created. So here we are. There are no collections in that cluster. This is just brand new one. But now in order to use the inference mode, I just need to enable it. But currently it's just enabled by default for the newly created clusters. So we provide a couple of models, the most popular ones, the ones that our users use quite often in their projects. However, if you see there is a model that you would like to include, you already use it, please let us know. We are just open to any discussion about the models you want to see here. But just as a starting point, we decided to take these ones, which are quite popular. And similarly to LLMs, here you don't pay for the model to be idle. You are just paying for the tokens you use. So the cost of each model is presented on that list. However, BM25 embeddings, sparse embeddings, quite popular. They use as a baseline in many third applications. They are just totally free. So if you just want to build a lexical keyword-based search, BM25 is completely free, and there is no need to worry about the cost of that. However, all the rest of the models is also really cheap. The textual embeddings, the best that we have from Mixed the large ones, cost as little as 2 cents per million tokens. So the cost of that should be negligible in many cases. And you are also getting a few million free tokens monthly for each of the models. And one interesting thing that actually allows us to build multimodal search is a clip model. There are actually two variants here. We have a separate model for images. It has a different input. You just need to pass an image. So that's why we decided to split that model into two separate entities. Here, maybe you are just using the image one. And we also have clip for text. It's actually the same model. We are just using different inputs to it. And you can also track the usage of each of the models. So if you work in a company and many people have access to it, you can clearly see like how much you just spent in the current month, in the current period. And when it comes to the usage, the actual usage, we have different tabs depending on the language you want to use. You can just select your platform and see an example of how to add and query using a particular model, which is kind of interesting. You just don't need to look up in the documentation. You can just go there and do it even from the cluster UI. So in our application that we'll be building today, we'll be using clip embeddings, both image and text. And the whole idea behind the application is to uh, simplify the process of decluttering your images. I don't know about you, but I personally find it really challenging to just manage my gallery on my mobile effectively. There are just lots of photos taken at some random moments. There are different objects on these pictures, and actually, I never find enough time to just sit down and organize them in any way. So I thought it would be really useful to have a mechanism that will allow me to search over them, group them together, and hopefully then applicate them and keep just the ones which would be interesting. And the main problem that I see with semantic search alone is that if I just took the embeddings of the entire images, then I could easily lose some information because they would rather describe the meaning of the whole image, not the individual objects that are presented on them. So I thought it also makes a lot of sense to apply machine learning models twice. First of all, to do the object detection, so I can not only encode the entire images through the clip model, but also encode these individual images and get the representation of all the people that appear on all of my images, of hopefully all the other objects which are presented there. And actually, I combined multiple tools in order to achieve that, but we'll discuss the implementation later on. Before we start, I also wanted to highlight the Python SDK, how to enable cloud inference. I just feel that Python SDK is just the most popular one that we have. So whenever you connect to Qdrant, you have to create an instance of the Qdrant client. That's nothing new, and when you connect to cloud, you also have to specify the API key because the access is restricted by default. So now, if you decide to use cloud inference, you just need to set up the flag cloud inference, set it to true. And that's actually the only change if you used fast embed with local inference in the past. Because then when you either observe or search, you are not providing the vector representation as you were supposed to do just a few months ago, but you are passing an instance of a document, which is just a new model. This is a Pydantic model available in Qdrant Client. And then you pass the text and the model you want to use to encode that text. You can also pass an image. If you just click on the image embedding, here is how it's gonna look like. We are passing an image and similarly the model. Currently, it's the only model that supports vision, but probably there will be just way more models supported in the future. And then we observed, as we were observing in all the previous versions of Qdrant. And coming back to the text example, here we also have an example of how to query that collection. Instead of passing a query vector to the query points method, we are passing a document instance with the text and the model provided. And that's it. So the logic here is pretty simple. By the way, if you have any questions regarding the cloud inference or the application we'll be presenting, please feel free to use our Q&A section so I can just answer all the questions at the very end of that session. I already see there are some questions in the chat, so let me maybe just answer them right now, and then we will just dive into the implementation itself. So the first question is when is it coming to EU regions? So as far as I know, the cloud inference in the EU regions should be available this year. However, if you have any project that you would like to migrate to use cloud inference, feel free to just send us this request. We're definitely open to discuss that and implement that feature in the regions that you want to support. earlier than in the others. It's actually really depends on the adoption of that feature. And another question is, do you support all multimodal models or just a selection? Well, we do not support all the models that exist. Obviously, the selection of the models is one of the things that we need to decide on. We can't just provide all the models that exist. There are many proprietary models which are quite popular, like provided by some of the LLM providers as well. And there are also models that have that can be easily converted into the format that we internally use. So we just have this selection. But if you have, again, any requests regarding the models we should support, feel free to send us a message. You can also reach me directly on LinkedIn or Twitter, and I will be happy to just discuss that internally with our team. That's just the beginning. We have just announced that feature, so definitely the list of the models is going to change pretty soon, depending on the request from you. And one last question that I just missed is it cloud inference available on self-hosted Qdrant? No, actually, uh, since the architecture of that is pretty complex, like you need to set up an inference server, and that's actually only available in cloud. Obviously, that's one of the benefits of using the managed cloud. However, you can use these models also in the local inference mode if you use fast embed. So fast embed can also use these document instances. The only difference here will be that you won't be setting cloud inference to true. You will be just connecting to Qdrant similarly as if you were connecting to like non-managed cloud instance. So that would be the only difference. And then you also pass a document with text and a model, and fast embed will handle the vectorization process on the specific machine you will be running that code on. That's not the same, as like the managed cloud solution, because here there is like a separate inference server that takes this load generated by creating the vectors. But from the code perspective, that would be the only difference. That also makes it easier to test your applications locally. Like if you build an application, if you are building an application, you definitely need some sort of development environment, or perfectly you just set it up using some containers on your laptop, on your machine, so you can just see the changes immediately. And then in that case, you can just use fast embed for the development environment and cloud inference in production. That also makes a lot of sense. So that's why we implemented a universal mechanism that is common for all the modes of running Qdrant. And then you can just choose whatever works best in your specific scenario. How about integrating embedding endpoints? I'm not really sure what you mean here. Feel free to use the Q&A section just to send like a more detailed question, because what do you mean by embedding endpoints? Like, you mean like providers such as OpenAI or Cohere, or maybe some specific service that you use? So it's a bit unclear to me. But I would just try to answer all the questions at the very end of the session. Right now, we can just switch to the implementation itself. This repository will be public, and you will get a link to it in the email, in the follow-up email after the webinar, sent in the upcoming days. However, it's not public yet. We are just trying to publish them after the webinar. So the structure of this repository is pretty straightforward, hopefully. This is going to be a full stack application, not a CLI application, because I just find them pretty hard to follow. So there is a front-end layer that we won't be speaking much about, because it will just integrate cloud inference, actually the API built on top of cloud inference with the interface. So we'll definitely have a look at the running application. But the most important part is how we build a backend. Backend is just a standard fast API app. So there are some mechanisms such as setting up Qdrant collection when we start the application, just to make sure there is a collection on that specific cluster created. And there are two sets of endpoints. Actually, each of them is no more than just two endpoints. So we have a search mechanism and an ingest mechanism. So we can use the same UI to send some images, and they will be processed. And we also have search that allows us to find something which is just relevant in our specific case. So let me just open the first set of routes here and ingest, as this is the first step of every application. We combined multiple tools to build that up. So we not only use Qdrant's client with Cloud Inference, but as I said, we want to use this object detection mechanism in order to extract all the entities that appear on a particular image, and then have multiple vectors created for a single image that will be represented at separate points in Qdrant collection. I think that makes a lot of sense. Like, Clip is not able to capture all the nuances. So, for example, if a lot is happening on a particular image, then it's probably better to just detect these objects, have another encoding of the whole entire image, and then search will be easier if we're interested in seeing like all the images with cats, different kind of pets, maybe flowers, etc. And there are already some pre-trained models that we can use. I actually found Supervision interesting. Supervision is an open source project that provides these models in an easy way, so we can not only detect but also visually annotate pictures with the detected objects. And YOLO is just a family of models from Ultralytics that can provide that functionality. So this is pretty straightforward. This is configurable by an environmental variable. We can set it up here. You can just select a different model if you prefer. But however, this is the latest generation, so I thought it should be just the best to use what's the most recent. So we create an instance of the YOLO by passing a name of that particular model we want to use. And then this model might be used with supervision for the detection of the objects. So what happens when we ingest an image? So this will be a post endpoint that takes a specific request, and this request contains just an URL of the image. So it doesn't necessarily work directly on our mobile phone. I just wanted to present a functionality. So obviously you could run it on your mobile phone, but here it's just a publicly facing application, so it's just easy to send a URL to an image. And whenever we receive an image, we download it and make sure that this is actually an image, because like we are just passing an URL, so somebody could just send us anything, and we just don't want to run some potentially malicious code. So definitely checking the content type is like the bare minimum that we can do. And when we download the image, we perform object detection on it. However, in order to create the embedding of the entire image, we don't really need to do that. If you were just supposed to encode the entire images in your project, then you don't really need to download it at all. You can just send it directly to the to Qdrant with Cloud Inference enabled, just by passing the URL. This is the first mode. There are some restrictions here. If you use images with Cloud Inference, the maximum size of an image is 4 megabytes, and PNG and JPG are the only supported formats. So there are some limitations, but then this image will be downloaded by our inference server, so there is no need to load it in your application. However, in our case, we really wanted to download it locally, because that's what we need for making the object detection works. And then the model was just a YOLO instance. We need to set a specific confidence threshold. Obviously, we could just play with it, and probably it would be just better to run multiple experiments to determine what's the best threshold in our specific case. Like, you have a set of images and you really want to find all the objects, then you play a bit with them, with that value, and just see what works. I just set it to 0.5 because I thought it would be just okay. However, when we look at the running example, you can clearly see that some of the objects are just not detected. So maybe it would be better to just lower our expectations and allow a confidence to be just a bit lower. And here we start using supervision. Supervision has a pretty unique interface. You can just pass the results coming from multiple providers of the object detection models, and Ultralytics and YOLO models are just one of the examples here. But then you can just choose different providers and send the results, and the output will be just unified. So no matter what model you use, what provider you use, you can still detect your objects with supervision, and I find that pretty cool. Then the detections might be iterated over, and we receive multiple pieces of information here. So first of all, we receive a bounding box, so where exactly this particular object was found. There is a confidence measure, which in our case shouldn't be lower than 0.5. There is a class ID. Obviously, these models can only detect a particular set of classes. So definitely people, cars, etc. But if you are interested in seeing all the possible classes, then you definitely need to check the website of the models provider. And that also depends on the model family you use. So that's pretty interesting information. Definitely worth keeping in the point payload that we have in Qdrant. And data actually contains some additional metadata information. There is also a class name provided as a string here when we use YOLO. So it's just way more convenient to operate with the class name instead of the class ID. So that's what we do. And also, we did this object detection for a purpose. We wanted to have multiple embeddings per single image. So that's why we use a helper crop image function from supervision that takes just a part of the image that represents this particular object. And then it's no longer a file, or there is no valid URL we can pass to the cloud inference uh, supporting Qdrant instance. But we need to send it in a different way. And it's of course possible. There are many cases in which you can't really provide a valid URL because maybe a particular resource is just not publicly available. In that case, you can also send a base64 representation of that image. Here is how we can encode this particular part of an image, this particular object, as a base64 string. Those of you who has even just a little front-end experience, if you have ever created a website, then you probably know that you can also do it in HTML when source is just a base64 encoded string, and this image will be also rendered properly on your website. That's what you can do exactly in the same way here with Cloud Inference. So even if you pass it to the Qdrant instance through the point structure, you can either provide the URL or the image, and that's totally fine. The same model as in the previous case. So that's actually it. And this whole process is actually building a helper list that contains all the points. So if we pass a URL, that will be a valid image, then definitely there will be at least point created for the entire image. And then the object detection should also create some additional ones, so we can have all the objects encoded as well. On the final note here, for the entire image, the payload is a bit simplified. We have just the URL and its shape, which is the width and height of an image, which is kind of helpful when we want to render it. But for the objects detected on the image, we not only encode the URL and the shape, this is identical to the previous one, but we also keep the name of the class that was detected and the confidence as returned by the model we selected, and the bounding box boundaries. It is pretty helpful to present that visually in the UI. Then we delete all the points for that URL in order to avoid having duplicates. if you just ingest hundreds of images into the system, you may easily forget at some point that maybe this image has been already put. So this is actually a pretty good practice to just remove before uploading new points. And that's basically it. At the very end, we upload all the points with batching enabled, and the inference server of Qdrant will just do its job and convert all the images, all the objects into proper vector representations, and these vector representations will be kept inside of your collection. So here is it regarding the ingestion pipeline. And now let me just dive into the search. And search might be pretty complex at the first glance, but let's just review the search request model, which is a representation of a request. So different parameters, but all of them are just optional. So we can provide a query. Obviously, if you are interested in seeing a particular set of images, like show me all the red cars, you will pass red cars as a query. You can also provide a number of points you want to retrieve for your query, which is kind of typical. A minimum confidence, that makes a lot of sense if you just want to filter out the objects that the model was not certain about. And also filtering by class. Here you can just provide a list of the classes you want to see. For example, you would like to see all the pictures with, I don't know, Santa Claus. So there is no need to just browse all of them. This filtering is pretty nice to have. And this is it. Obviously, if you do not provide any of these attributes, we will be just served with some of the points, and this is handled in the search endpoint itself. So here we built this filtering conditions. This is not that important probably to just get through all the filters which are built here, but it just reflects all the criteria we have here. So confidence and class name. And here, when we search, there are two scenarios. First of all, we have a query provided. So when we have a query, we also create the document instance with that query sent as a text. And here, this time we also use clip model, but this is this textual variant. So it is capable of taking text and converting it into a vector. However, if no query is provided, we just run query points. It won't be like a set of random images probably, but it's probably going to be more like a set of all the same images whenever you just launch it. However, it just for clarity, you could probably think about implementing some score boosting here. So you just prefer some of the objects in that filtering. And that's basically it. Here we have some conversions, so it's just easier to consume by the UI, and that's basically it. So those two functionalities were implemented just by using Cloud Inference. There is no model running on my machine or somewhere else. I will be just sending this request directly to Qdrant Cloud instance that I have. So in order to run this application, we would need to set up the configuration. The easiest way is to just copy the env example file, create a .env file in the root directory of the project, and by filling all these values, by providing a valid Qdrant URL and API key, and setting up the collection name, we can just configure it to run for our cloud instance that we have just created. Then you need to build an image. That will be a Docker image that will contain both frontend and backend. And run script will just run that application in a Docker container, and it will expose it on a specific port. So that's actually it regarding how to run this application. And one great thing about that repository is that this is also compatible with Hugging Face spaces. So you can actually run it on Hugging Face spaces easily without even worrying much about the environment where you could possibly experiment with it. One thing that I should probably mention, this is not that much related to the cloud inference, but in general to how we use Qdrant properly. is how we set up the Qdrant collection. So obviously we load the configuration from the environmental variables. That's kind of typical. We create the instance of Qdrant client. This time we don't really need to have a cloud inference enabled. We are just setting up a new collection, so it's not required. However, you need to set it up whenever you search or insert some data. And like creating the collection is like a typical process. We just provide a list of named vectors or just a vector. I just prefer to use named vectors all the times. Uh, and we provide a size of an individual embedding, which is 512, which is obviously defined by the model. We use the cosine distance as a similarity measure. And one important thing, if you would like to have this filtering capabilities, is to set up the indexes on all the payload attributes you will be using for filtering. So because we are deleting the old points with the same URL, I created a keyword index on the URL key. I also created a class name class name index also of the keyword type because we want to filter by the class name. And the confidence, which is a float index, because the filtering by minimal confidence is also something I wanted to have. So this is how you should set up your collection if you want to perform semantic search with some filters on top. And coming back to the cloud clusters we have. This is a brand new cluster I created, but obviously I have also created another one that already has some data inside. So let me just switch to it. And there is just a single connection, which is called images. And here you can see how this point will look like. So this is an object detected. It's quite hard to say like which object was detected from that picture and from this coordinates. However, we'll be just displaying that in our UI. There are also some other images here, and I wanted to find the entire image because the structure will be slightly different. However, yep, and this is also an entire image, so we only have the resolution of an image and the URL. By the way, if you haven't used our UI, this is pretty interesting to just have a look because the images are also rendered here. So even if you just want to inspect the data you have inside of your collection, that's the easiest way. And there is also a console, which I really like, especially once we introduce the cloud inference mode, because here, if you want to search for some points fulfilling your criteria, you no longer need to pass a query vector that you would need to pass in the previous versions before the cloud inference release, but you can also pass the name of the model, the text query, or even a URL to an image if you would like to perform reverse image search, and then you can run it. And as an output, we will have a list of points with their individual scores that just that were returned as the best matches. And there is also an interesting statistics here, like how many tokens you used in order to generate that. So for simple queries, we are not using more than just a few tokens. So this is kind of cool, and especially for lower scale applications, when you don't have lots of data, you could possibly run it for free. No need to pay for the embeddings. And in many times this free tier limit should be just enough. And I would like to present you the application that I've created for the purposes of this webinar. This is not public yet, but will probably be public in a few days. Just need to think, probably it's not a good idea to just expose all the functionalities, because here you can also ingest some images. Like you can pass a URL to an image that you would like to add, and this object detection will be just launched under the hood, and all the objects will be represented as well as the entire image. But you can also search using textual queries. There are some examples, and you can filter based on some classes that as detected on all the images. There is also one endpoint that I forgot to mention or just missed on purpose. Uh, it exposes this selection of filters you can apply. There is like it's just good for the user experience to have a preset list of all the possible filters. And for that, you can use the facets API we have in Qdrant. We also have a range filter, so you can set up the minimum confidence. If I just set it to 100%, then probably I will only get the entire images because none of the objects was created with such a high confidence. But if I just lower it, some of the people were just selected with pretty high confidence. And okay, so this is how it looks like. Let me just set it to 0. But here you can see how it looks like. So we have a lot of people on these pictures. You can clearly see that some of them are just detected on this image. But if you would like to see only some relevant examples, like only the cars we have, you can easily just click on the filter, maybe add a bird. Oh, was that a bird? Not really. I'm not responsible for the model itself. Unfortunately, it's not able to detect all the possible examples. However, there is some kind of an animal, so maybe it's not that far. It's not a pizza, at least. And when we detect a pizza, yeah, there are also some images of pizza with different confidence level. Um, so we have all the details about the particular image. If you just unclick all the options, uh, select all maybe, and click on an entire image. Is there any entire image? No, clear all. Okay, and for the entire image, we just see the resolution or the metadata information, and that's basically it. So if you're interested in running that application for your own purposes, this will be fully open source and available in our GitHub repository, and you will receive a link to it after the webinar in the follow-up email. So I just encourage you to have a look and experiment with it, especially if you could just send your own images. This Hugging Face space will probably also get exposed, but I will just disable the ingestion endpoint because I just don't want to deal with all the images that some people in the internet can send to that service because they will be just publicly visible here, but maybe we'll add some more examples so you can just experiment and see whether you like it or not. And that's what we implemented with Cloud Inference without setting up any infrastructure for the embedding models. I think that opens a completely new set of possibilities. For example, if you would like to implement a front-end only application and expose a search functionality for your users, you could possibly combine Cloud Inference with read-only API keys from Cloud. So all the people can just access Qdrant from your front-end application without even setting up any kind of backend, because they will be just able to send the URLs of the documents or maybe the textual queries they want to search with, and there is no need to worry about the backend if this is just a simple application. You can just send them directly. Previously, you would need to create these embeddings, and that means you will either communicate with a running embedding model. It's pretty hard to run them in browser, for example. However, it's pretty easy to just send the text and skip that entirely. So that opens some huge possibilities regarding building some applications in a simpler way, especially if you build browser extensions or simple front-end applications. Then you can finally use semantic search without any additional services. So that really minimizes the complexity of your search stack. So hope you like this idea for an application. And right now, let me just answer this question. I can already see there are some questions in the chat. Let me just continue with them. The first one is about the recordings. Yeah, definitely we put all the recordings on our YouTube channel. So if you'd like to watch them again, feel free to just check our YouTube channel in a few days. The recordings should be available, I guess, tomorrow, maybe Monday in the worst case. And I didn't understand your comment regarding serverless running 24/7 when using local models, and what is Qdrant Inference solving in that regard. Yeah, actually, my point was that when you really build a production-ready application, you rarely embed the embedding model. Well, you rarely put the embedding model into your application directly. I mean, the embedding models are pretty huge sometimes, and the good practice is to just run them as a separate service. So I don't want to call them like a microservice, but specifically there is a separate API that you can call in order to create your embeddings. Um, Imagine you are just building a web application with many concurrent users. And in that case, you typically have lots of processes in your HTTP server created. So you can handle multiple requests at the same time. And each of this process would need to have its own copy of the model in the memory. So even you have like a 1 GB embedding model, which is not that huge, you would need to have, I don't know, like 8 GB of memory just for the model, even though it's not used. So it's usually better to have a separate service that will be scaling up and down the embedding model, or when maybe it will just have a few processes running, and then you keep the main application lightweight. So it only uses the resources needed to serve the request, and there is no heavy processing inside the web application. This is actually a pretty good idea to delegate this kind of tasks somewhere else, and we do that quite often for, I don't know, like PDF generation or very heavy processes that we don't want to be blocking the threads of the HTTP server, because we want to asynchronously serve multiple users when we wait for some I/O operations to finish. So I would consider the creation of the embeddings to be an I/O heavy operation, and that's why I would delegate that to external service. And then, if you still decide to just put the embedding model inside of the application, that means you are actually wasting your resources. It's running 24/7, even though you might not be using it. Like the typical flow of the semantic search is that you have an ingestion pipeline in which you need a lot of resources in order to generate the embeddings. And that's why this cloud inference makes a lot of sense if you have like heavy ingestion pipeline at the very beginning of the project, and then you just rarely update it. So you can just use the cloud inference to do this initial ingestion, and then when you query, you just rarely access your model. So like in that case, this is a waste of resources, and if you just use cloud inference, you don't need to worry about the cost of that. Um, Another question or a comment. So each image will be many points. What about each image is one point with many vectors? You have something called hybrid search, but the issue is that, if I'm not mistaken, the number of vectors per point should be a fixed number. I was wondering if there would be an option soon where we can have a variable number of vectors per point or data log. Yeah, the problem here is that if you have multiple multiple vectors per point in a quadrant collection, those vectors has their names, and these names are used to distinguish them and to build this internal data structure that we use for search, uh, namely HNSW index. And this HNSW index has to be created on the vectors at the same time. So you can't really combine multiple named vectors for that. Actually, I was wondering about the best way of how to implement that. I thought maybe it would make some sense to just use multi-vector representations, so combine all this object embeddings. However, I haven't tested that, so maybe that makes some sense. However, in that case, it also works pretty okay. So we have this multiple points, and it's not a huge problem, because eventually we are using the same model to create this embedding. So why can't we just keep like vectors the main entity here, and just decide that a particular point should have just a single vector? It's just way easier. But I agree, there is not a single way of how to solve that. Use case, semantic search over a knowledge base from thousands of PDFs. How would I treat PDF which contain of many pages? Turn PDFs into images, extract the text, and send both as document to Qdrant. The challenge is understand text and images within each PDF. Yeah, so definitely there are many ways of how to handle that. If you don't care that much about the images, diagrams, and only the text is an important asset in your assets in your PDF files, then probably it's just better to run OCR. However, I'm not really sure, and probably it's not the best model. I mean, the clip model is not the best model regarding this kind of problems. If you really want to care about texts and images at the same time, it's probably better to use something specialized for that, like ColPaly with multi-vector representations. We had a pretty interesting article on our website describing exactly how to achieve that. So I would recommend you having a look at it. And for that, Cloud Inference does not support multi-vector embeddings yet. Hopefully they will be integrated. If you have a very specific use case, feel free to let us know. I'm definitely eager to discuss the possibility to add multi-vector embeddings in the nearest future. Uh, Okay, a little outside the topic of this webinar, but what's the best performing latest clip-like model now? Yeah, actually, that's a pretty interesting question. I unfortunately do not track this. I'm not really sure if there are like some leaderboards like we have for the text embedding models. MTEB is a pretty standard for text embedding models. However, I'm not really sure if there is something similar for the image embeddings. It's probably a bit harder to build a proper ground truth data set to test it thoroughly, so I'm not really sure. And let me just open the Q&A section then. What happens if you have a cluster on an older version without cloud inference and upgrade to a version that supports inference? Do embeddings for existing documents get auto-created when we enable inference? No, actually, the embeddings are only created when you ingest some data and when you specifically pass an instance of the model of a document or an image. So you are explicitly requesting creating the vectors by the inference server. So that's where this vector creation happens. But all the existing vectors won't be affected by that. So no risks here. You are not paying for creating them again. Yeah, but this is pretty cool. If you used any of these models, then you can easily switch to cloud inference and still get the same outputs because that's ultimately the same model. So it's compatible with your existing ones. So this is nice. Like the migration is really easy. There is no need to recreate vectors for all the existing points you may have. I know you did not want to talk about chunking, but from what I see, I'll have to do the chunking before sending it to cloud embedding. I guess I would need to provide the corresponding metadata with the chunk. Is that correct? Yes, exactly. You would need to build your points, and you won't be just passing the embeddings, but you will be requesting to create the embeddings with a particular model. But all the payload attributes have to be provided by you. So you explicitly need to provide them for every single chunk you want to have in your collection. So that's correct. And the last question is, why don't you use Jina embeddings? It looks like could be a good solution to embed documents. Yeah, this is actually a good idea, probably. Jina embeddings are great. I also like them. I use them from time to time, and they are really great. They also excel if you have a look at the actual benchmarks. So yeah, definitely that's a good idea. If you have a very specific use case, maybe you use a very specific version, please feel free to let us know. We are definitely open to adding some new vectors, but we are just not adding all of them at once. You can also imagine like that requires to have an infrastructure on our end and supporting all the possible models. If there are no users of these models, does not make much sense because obviously we can't get rid of the models easily after. So we just try to keep this list well curated and just add new models on request. And also the last comment in the chat, let me just read it. Is Qdrant able to do search using two vectors and return the results based on some normalized score from two vectors? You are actually speaking about recommendations. So you have the same model, but just two positive and negative examples. Is that correct? If so, yeah, we have a recommendation API, and right now it's all unified under the universal query API. So this query points method that I used in that demo application is the one that you should be looking at. So there is a possibility to run a recommendation query when you can pass multiple vectors, and yeah, that's supported. You can also query Qdrant with multiple vectors at a time, and they might be positive and negative. So this is pretty interesting. If you build a recommendation system, then you can pass the items that a particular person like and dislike at the same time and get some matching results that will be close to the liked items and far away from the disliked items at the same time. So you can also optimize for multiple objectives here. Just to put it like here. Since I don't see any other questions and we are actually running out of time, I'm really happy that you decided to spend this hour with us and join our webinar. Please feel free to reach me out on LinkedIn or on Twitter if you have any questions regarding the content that we presented today or any questions related to cloud inference or Qdrant in general. And that was a real pleasure to be speaking to you today. My name was Kasper Rukawski, and yeah, looking forward to seeing you on one of the upcoming webinars that we'll surely have in the next months. Thanks, and see you.